Okay, today we're looking at 1.4, and we want to measure, classify, and identify angles and a bisector of an angle. So first we have some vocabulary. So the first one is a ray. Ray is a part of a line with one endpoint that extends forever in the other direction. So that's going to look like this. That's a ray. Opposite rays would be if you chose a point on a line. So here's my line, and I have a point right in the middle of it there. Those are both opposite rays then. An angle is formed by two non-collinear rays that share the same common endpoint. So you've seen angles before. That would look like this. The interior versus the exterior of an angle. If I have an angle like this, this is considered the interior on the inside. Oops, sorry, you can't see that. Interior. And this is the exterior on the outside of the angle here. So interior versus exterior. A degree is how we measure angles. There's 360 degrees in a circle. And the angle bisector divides each angle in half. So then below we have three different types of angles there. So we have the right angle, which measures exactly 90 degrees. So that's going to look like this, and it will be denoted with this little box in the corner there. Even if it doesn't look like a 90-degree angle and it has that, that means it is a right angle. We have the acute angle, which is less than 90. So anything like this. And an obtuse angle, which is between 90 and 180. So larger than that 90 degrees there. Okay, so in our examples, it says use the figure to the right, and we're going to name all angles that have B as a vertex. So B is right here, this point. So we actually have angles, you can see here, angle 5, angle 6, and angle 7. Those are quick ways to name them if they are numbered like that. So 5, 6, oops, should put the angle symbol there, and 7. And then I also have this angle here, but we can't just name that B because there could be more than one angle with B on it. So we're going to name it ABG. So those all have B as a vertex there. Okay, part B says name the sides of angle 5. So the sides of angle 5 there, if I look at angle 5, that's right here. I have that spot and that spot. So I'm going to call this ray BG. And we're going to put the arrow on one side. That is geometry language for saying that this is a ray. And then BE or BF would be the other one. I'm going to use BE. If you want to use BF, that's fine too. And then the next one says write another name for angle 6. So angle 6 right here, I could name that using the letters. So I could say DBE. That would be one possible way. I could go the other way around. I could say EBD. But notice how the B has to be in the middle here. I could also use the F. I could say FBD or DBF on there as well. Those would all work. Okay, example 2. It says classify each angle as right, acute, or obtuse, and then use a protractor to measure it. So if you don't have a protractor with you right now, that's fine. You can just watch me measure it when we get to that part. So TYV. So I'm going to come over here to my diagram and look at TYV is this angle right here. So if I look at this, this is creating a straight angle, TYX. And if this is marked as 90, that means that that also has to be 90. So this is going to be a right angle, which means it's 90 degrees. And let's measure that just to be sure. Grab my protractor. Okay, so if I look at this, and we might have to extend these out a little bit. So I'm lining up my center spot here. and lining up this line along here, and I'm looking at where does this line go. That is at my 90 mark there. I didn't draw that line perfectly straight, but that should be 90 degrees. Okay, the next one is WYT. So WYT would be right here from W to Y to T. That would be this. Okay, so that, you can see that is larger than 90 degrees, so this is going to be obtuse. And let's extend those lines out so I can use my protractor again. Okay, so I'm going from here. Now if I'm measuring from this side, I'm going to start at the lower numbers here because this would start at nothing and go over to my angle. So if I measure along here, that lands at the 130 degree mark on there. You can see that right there. So this is going to be 130, which does confirm that I said it was obtuse. Okay, and the last one on that example, TYU. So if I look at my picture again, I have T, Y, and U right here. So that is just this little spot here, which is going to be acute. And then I'm going to measure those again. So let's extend this. Okay, so if I know it's acute, I know it's going to be less than 90. That's something to help you when you're measuring. Because I look along here, and it lands between the 40 and the 50, or between the 140 and the 130. But if I know if it's acute, I'm going to go with the angle that's between the 40 and the 50 there, and it's right exactly in between, so I'm going to say that is a 45 degree angle. Okay, last one, example 3. It says find the measure of GBH and the measure of HCI, given that they're congruent to each other, so that means that they are the same measure. And we have that angle GBH is 2x plus 5, and angle HCI is 3x minus 10. So since I know that they're congruent, I'm going to take those expressions and set them equal to each other and solve. So I'm going to get my x's all on one side, then get the x by itself. So this is going to give me x equals 15. And I'm going to keep preaching this. You always have to go back and read what it was actually asking you for, which was not what x was. It wants you to find the measure of those angles. So I'm going to take one of them and plug it in, because since they're equal, it should get the same answer for both. So I end up with 35 degrees for both of those angles. Okay, so you have the last two to do. So in this diagram, name a right angle and then classify that angle. And lastly, your joke of the day. Why did the butcher work extra hours at the shop? He needed to make ends meet. All right, I hope you have a lovely day and be nice to someone today.